All right, today we're talking about a software model for when things absolutely, positively have to work. We're talking about situations where failure, yeah, it's just not an option.
Seriously, just stop and think about this for a second. How on earth do you write the software for a rocket launch? Or for, say, a country's entire banking system?
I mean, in these kinds of jobs, you don't get a do-over. One bad line of code, just one, can cost millions, or, a lot more. This isn't Silicon Valley's move fast and break things. Nope. This is all about get it right the first time, every time.
So let's just dive right in and look at these high-stakes environments with this level of care is, well, not just a good idea, it's absolutely mandatory.
Yeah, we're talking about things like NASA space projects, right? Where lives are literally on the line. Or the software that runs our entire financial system. Imagine the chaos if that goes down. Even the code inside an MRI scanner, a tiny glitch there could have huge health consequences. For these kinds of jobs, you need a totally different playbook.
And that special playbook? Well, that's what we're here to talk about. It's called the Spiral Model. It was designed from the ground up for exactly these kinds of complicated, super high-risk projects.
So this idea came from a guy named Barry Boehm, way back in 1986. And it's really a mix of two big ideas. First, you build things in small, repeated cycles, iterations. But second, and this is the absolute key, every single one of those cycles kicks off with a deep dive into risk management. The name Spiral is actually perfect when you think about it. Picture the project spiraling outwards. With every single loop, the software gets a little bigger, a little more complete, but the whole time you're constantly looking over your shoulder, always asking, what could go wrong here? Okay, so that's the big idea, but how does it actually work in practice? Well, the whole thing is powered by this really simple, repeatable, four-step loop.
Think of these 4 steps as the engine. First, you plan what you're going to do in this little cycle. Then, and this is the important part, you do a risk analysis. You literally ask, what could blow up in our faces? Only after that do you actually start the engineering, the building and testing. And finally, you wrap up with an evaluation, where you show it to the customer and get their feedback. That feedback then feeds right back into the plan for the next loop of the spiral. It's this constant cycle of building and checking for danger.
And that's the whole magic of it, right there. You're not trying to build the entire thing in one go. You just plan a bit, check for risks, build a bit, get some feedback, and then you do it all over again. The project just gets stronger and more reliable with every single pass.
Okay, that's enough theory. Let's make this feel a bit more real. We're going to walk through how you'd build a pretty common feature using this exact method.
Let's say our job is to build a secure payment feature for an e-commerce site. Sounds pretty standard, right? But man, there are a ton of things that can go wrong with payments. So for our first spin around the spiral, the plan is super simple. Let's just build a basic credit card payment system. The biggest risk we can think of? The payment gateway failing right in the middle of a purchase. So for the engineering part, we whip up a quick prototype using a fake or dummy gateway just to test the basic flow. Then we show it to the customer. They're like, cool, this works. But they immediately say, hey, for security, we really need OTP verification. Okay, so now we head into cycle 2. The new plan? Add that OTP verification. But wait, that brings up a new risk. What if the user's internet connection dies while they're waiting for that OTP code? So our engineering phase now involves building a retry mechanism. We build it, we test it, and we show it to the customer again. And this time they're super happy. We've got a secure, reliable feature, and we've already stamped out 2 potential disasters before they could happen. So you can see how this works. It's pretty powerful. But does that mean you should use it for every project? No, absolutely not. Let's take a look at the pros and cons. The upsides are pretty huge, right? You get amazing risk management, tons of customer feedback, and usually a very high-quality final product. But there's always a but. All that careful work comes at a cost. It's expensive, it's complex to manage, and it can be really, really slow. It is complete and total overkill for a small, simple project.
Now, to really get where the spiral model fits in, you have to see it next to the other big names in the game. Agile and waterfall.
And this chart really lays it all out. You've got waterfall on one end, which is super rigid. It's great if you know exactly what you need and nothing will ever change. Then you have agile on the other end, which is all about flexibility and adapting to change. The spiral model, it carves out its own space right in the middle. Its killer feature isn't flexibility, it's that intense focus on handling risk. It's the perfect tool for those high-stakes projects we've been talking about.
So here's the bottom line.
You wouldn't use a surgeon's scalpel to chop carrots for a salad, right? The Spiral model is just like that. It's a precision tool. You're not going to use it to build a simple blog or your startup's first MVP. It's built for those times when the cost of getting it wrong is just way too high to even think about.
And that kind of leaves us with one last question, doesn't it? In our modern tech world, where everything is move fast, move fast, move fast, does a slow, careful, and kind of expensive model like this even have a place anymore? Well, I think as long as we're still trying to send people into space, or run the world's economy, or build medical devices that keep people alive, yeah, I'd say the answer is a definite, resounding yes.